Hi everyone, so in this video we are going to talk about the atomic structure or the architecture of the atom. As a review, we have discovered and we have explored the different atomic models, and we get to learn how those models were constructed or were developed by their proponents. Now we delve deeper and we refresh ourselves with some basic concepts about the atom, right? So the part that concerns us is basically the three subatomic particles, which are the protons, neutrons, electrons. Okay, and then we know that in higher physics there are a lot more of subatomic particles. So after protons, you have smaller quarks, then a lot of other elementary particles after that. Okay, but we won't concern uh, ourselves with them just yet, so we focus on the three. Okay, we know very well that protons are positively charged particles that reside together with the neutrons inside the nucleus. Now, neutrons are zero, have no charges at all. Okay, they are electrically neutral. However, the nucleus is surrounded by a cloud of electrons which are negatively charged and which are way smaller than your protons. Okay, so here is a more accurate diagram or representation for the atom. Okay, according to the electron cloud model, the electron is actually um, both particle and wave. So it exhibits wave-particle duality. And according to the uncertainty principle, we cannot determine both the location and the speed of the electron simultaneously or at the same time. Okay, so all we can think about is probability, okay, or the likelihood of finding an electron there. Now, this gives us a more accurate representation because the darker areas actually are used to represent a uh, more probable or more likely location for a particular electron in that area. Okay, the darker the shade, the more probable it is to find an electron in that area. Okay, so most of the mass and all of the positive charge of the atom are in the nucleus. Again, the neutron and the proton. Electrons occupy a huge volume in comparison to the nucleus, but have relatively small masses. Okay, and the protons, they account for the positive charge of the nucleus, and they have a positive charge as well. Protons have a mass about 2,000 times that of an electron. Again, the actual values are found in your module. Okay, and lastly, the mass of a neutron is more or less the same with that of a proton, but the difference is that neutrons have zero charges. Now we also like to review on the Bohr model of the atom, okay, wherein the nucleus is surrounded by the electrons traveling like planets uh, traveling around the sun. So they travel in circular paths called orbits. Okay, so electrons orbit the nucleus in energy level. So these are represented by these paths, the orbits, that have a set size and energy. Okay, the energy of the orbit is related to its size. The lowest energy is found in the smallest orbit. Okay, radiation is absorbed or emitted when electron moves from one orbit to another. So, for example, this red electron here, okay, if it moves a little bit higher, there is a specific amount of energy required for it to move an energy level higher up. Okay, and so since there is a specific amount, there is a fixed amount, it is said to be that that energy is quantized. Okay, quantization of energy. Now we also review on valency. When you talk about uh, valency, it gives us the outermost energy level or outermost electrons. So the valence shell is the outermost shell or energy level, the highest energy level, and the electrons residing on that shell are called valence electrons. Okay, these valence electrons are the outermost, the farthest from the nucleus, and they are the ones participating in chemical bonding and in chemical reactions. So again, those are the subatomic particles relevant to our study. Okay, and then you might have also remembered writing the nuclear symbols of atoms, wherein X represents the or is can be any element symbol. A represents the sum of the number of protons and the number of neutrons, while Z represents the number of protons. Okay, so Z also is also called your atomic number. The atomic number gives us the number of protons for that particular element. Okay, so no two elements have the same atomic number. This atomic number is specific only for a particular element or atom. It's like an atom's ID. Okay. Now, isotopes, these are atoms with the same number of protons but different number of neutrons. Okay, so in nature, you can have different, maybe different forms of, for example, carbon. Okay, you have carbon 12, carbon 14, carbon 13. Okay, and the difference lies within the number of neutrons. So they usually differ in the mass number and not in the atomic number. So here are a few examples. Okay. Now, for we see here that you have, for example, in the first oxygen, there are 8 protons. So how do we know that it's 8? We just look at the atomic number. And then 8 neutrons, because 16 mass number minus the atomic number is 8. Okay, and 8 electrons. So if you do not see any charge at the upper right corner, then we assume that the atom is electrically neutral, or meaning there is no charge. So the number of protons is equal to the number of electrons. Now let's take a look at the two carbon atoms, that is C12 and C14. Okay, so notice that there is a difference only in the number of neutrons and not on the number of protons. Alright, so another example is titanium, which can exist in many forms. So you can have titanium 46, titanium 47, titanium 48, 49, and 50. Now the percentages here represent the abundance of that particular isotope in nature. So if you look at the graph here, it is titanium 48, which is most abundant in nature. Okay, and this will have a relevant significance later on when we talk about the atomic mass of elements, which we will reserve for in our discussion on the periodic table. Okay. Now, there are 118 elements that have been identified and have found their place in the periodic table. Okay, most of them are naturally occurring, while some of them are man-made. Okay? And then the periodic table arranges those elements according to increasing atomic number or increasing number of protons. Okay? So how do we study? If you try to remember the features of the periodic table, or what's in a square for that particular table, we can actually see there the symbol of the element and its name. Okay, most elements names come from Latin words, okay, based on their description. Also, for example, Pb, that is lead, but its original word was plumbum. Okay, and we know very well how lead is used in making pipes or pipe system. That is because in the Roman times, plumbum or lead is used to direct and make water systems or pipes in that manner. Okay, so we can actually see atomic number, the symbol. This is the atomic number. It gives us the number of protons. The symbol is here, and then atomic mass, okay, which is actually the average of the isotopes for that particular element, and the number of valence electrons if we get to see its arrangement later, and the state of matter at room temperature. So in any commercial periodic table, ordinary periodic table. Okay, so atomic number refers to how many protons an atom of that element has. No two elements have the same number of protons. Again, this is just like an atom's ID. Okay, so in a neutral atom, or usually atoms have a neutral charge. If it isn't neutral, for example, if it is positively charged, we call them a cation. If it's negatively charged, we call them an anion. Okay, so and there is a difference in the number of valence electrons in those ions already. Okay, and so this is just a review of isotopes. Okay, so in terms of uh, charges, for example, an atom, most specifically the nonmetals, if they gain more electrons, 2, 1, or 3 electrons, they become anions, negatively charged particles. And then that is because they gained more electrons than the normal atom. And then cations, these are atoms with a positive charge because they have gotten rid of some valence electrons. They gave out, or they got rid of their valence electrons to become stable. Okay, and most of them, okay, in most cases, metals form cations. I hope you are refreshed with your junior high school chemistry lessons, and then please take note that we are doing this because chemistry as a body of knowledge builds up on previous lessons. Okay, it's foundational and it builds up on those concepts. So it's good if we remember almost everything that we have talked about in junior high, so that it will just be very easy for us to go with the lessons in senior high. Okay, so that's it for today, and thank you very much. Have a nice day ahead, and again, stay safe, stay healthy, and stay with your family. Make the most out of it.